This is 11.4, and it's really similar to what we did yesterday. So look at these two binomials. Those binomials have the same numbers, but the sign in between them is different. So those are called conjugates. And conjugates are going to be really important in algebra for the next couple of years. Okay? So let's see what happens when I multiply conjugates together. So 4y plus 9x and 4y minus 9x. So 4y times 4y is 16y squared. 4y and 9x make 36xy. Negative 9x and 4y makes negative 36xy. And negative 9x and 9x make negative 81x squared. Now notice the like terms are opposites from each other. And that's always going to happen when you multiply conjugates together. So we get 16y squared. Those cancel, and I get negative 81x squared. So anytime you multiply conjugates together, the middle term is going to be 0, and the resulting polynomial is going to be a special polynomial that fits this form. We have a perfect square minus a perfect square. So we call this a difference of perfect squares. So if I had the conjugates x minus 5 times x plus 5, when I put those in the multiplication box, I get x squared, negative 5x, 5x, and negative 25. The middle term cancels, and I get x squared minus 25. And notice that is x times x minus 5 times 5. That is a difference of perfect squares. And a difference of perfect squares results every single time you multiply conjugates together. Okay? So when you get good at these, you don't even need the multiplication box. We should be able to just do that in our heads. It's going to be x times x minus 7 times 7. And I don't need to write down the box. That will happen every single time you have a difference of perfect squares. Okay. So here, what is 6v plus 5u times 6v plus 5u? You might say 36v squared plus 25u squared. But it turns out it doesn't work that way. So I need to put these in the box. 6v, 5u, 6v, 5u, and I get 36v squared, 30 uv, 30 uv, and 25 u squared. Do these cancel? No. They're not opposites. They're the same sign. So 36v squared plus 30 and 30 makes 60 uv and 25 u squared. Okay? All right. Get to work.